We finally move to the last question in the writing part, the question number 20. It is to use L'Hopital's rule to compute limits in various cases. This term here, L'Hopital, right? It's pronounced as L'Hopital or El Hospital because it was written as El Hospital. This particular spelling, when you convert it to English, it means El Hospital. But then, the French writings changed and then they changed this words to O and this and they pronounce it as L'Hopital. If you have heard it as El Hospital, it's the same thing because back then it was written just like this. Now I'll be using it as L'Hopital and look at these problems. Now L'Hopital's rule basically revolves problems along the indeterminate form. Indeterminate form is something like 0 divided by 0 or infinity divided by infinity, or you can say 1 to the power infinity, okay, and then 0 to the power infinity or infinity to the power 0. All these are indeterminate forms, and then 0 multiplied by infinity, so whenever we get such forms, it's indeterminate form, nothing else. If it is, say, minus infinity, no, this is a limit. If it is infinity, it's a limit. 0 is a limit. 1 is a limit. Minus 5 directly limit. E to the power of minus 5 limit. So only when we get such forms, we can use L'Hopital's rule, provided there is a condition. It must be as a fraction like this. 0, 0 or infinity, infinity. It must be in this form, not in this. If we are in this, we have to convert it to this form. Anyways, we'll look into the problems. They're not very straightforward. You should know exactly how the method is, but starting problems are pretty simple. Limit at 0 positive side. Why is this 0 plus? Because what is ln of minus 1? Say, imagine minus 1. It doesn't exist. Or minus 0.0001. It doesn't exist. I will show you. It's better to use a calculator and check this. Here, let me take ln minus 0.0001. It's a very small, it's almost 0, but it's from the negative side. It's a math error because it's undefined. Why? Because if you look into the graph of natural logarithm, it starts like this. It's an asymptote at 0 and then it keeps on going. So that is the reason. Now, what about root x? Root x, you can have anything. That's fine. Sorry, again, not minus values. Let's try. Square root over here, negative 0.001. Do we get an answer? Math error, because we cannot have negative inside the square root, isn't it? You can have it outside. So that is the reason why you have 0x tending towards 0, but from the positive side. Now, do we need L'Hopital's rule here? Let us first always apply the limit and check. I'll directly apply 0 and ln 0. Now, what happens here? Here, when you start applying 0, it's 0 on the numerator. What is ln 0? You can just check it. ln 0 is basically, you will get undefined. Why? Because there's an asymptote, isn't it? But from the positive side, what happens? 0.001. It is a minus. Now, if you increase this, what happens? 0.0001. You're getting what? If you keep on increasing this, you will understand the limit towards 0 from the positive side for ln is minus infinity. How do you know that? Okay, that's a crooked line, but still, it's asymptote, right? At 0, it goes where exactly? It's going towards minus infinity. So the value over here will be 0 divided by minus infinity. Is this indeterminate form? 0 divided by anything is literally 0. So directly you can tell the answer is 0 here. The final answer would be 0. Why? Because the numerator is 0, whereas the denominator goes to minus infinity. So answer is 0 directly. You can tell it. There's one more thing you can keep in mind. Whenever you have ln, that is natural logarithm, infinity, or ln 0, from the positive side, obviously the limit will be towards from the positive side when it's 0. Here you need to understand this is if ln is, it'll be like this. I'll write the proper question and then I'll show you. Is limit x tends to infinity, okay, ln x, what will be the answer? That means you're applying x as infinity. It goes towards infinity along the x-axis, right? If you see the ln scale, it goes slowly and eventually it will reach infinity. So limit, when you apply the limit, sorry, after applying the limit, it will be ln infinity. This would be infinity, but it goes at a very, very, very slow rate, okay? So this is very important thing. Why? Because imagine you have ln x minus x, okay, just in case you have this term, and the limit is going towards x is infinity. Now here, yes, this ln also reaches infinity, then minus infinity, right? Both will be infinity. But look here, this reaches at a very, very slow rate, whereas this is more dominant. So you can directly tell the limit would be minus infinity. Though it's indeterminate form, you can tell it. But I will show you the writing method in the coming problems. So I'm just still trying to make you understand that whenever you have natural logarithm, it will go towards infinity, but at a very, very slow rate, okay? So the other value, if there is another infinity, that will dominate it. That's the thing. If you have x minus ln x, yes, this both goes to infinity minus infinity, but the answer over here would be just infinity. Why? Because x reaches at a dominating rate, whereas ln x reaches very at slow rate, okay? Now these are all the things which you should understand from these functions, okay? Because that will really help in the coming problems to analyze these problems. And since it's writing, you have to write it. Now one more thing before I move ahead. There is a direct way to check your answer in this. So it's square root x divided by natural logarithm x, isn't it? Close the bracket. If you want to check any limit, all you do is calculate it at that particular point. It's not 0, but you should take 0.00001 close to it. What is the answer? Here you can see it is negative 6 and minus 8. That would mean 10 to the power minus 6 is 0.12345. Then you are 5. This minus 4. Now, if I increase the number of zeros, you can see the number of 0.00, it goes more. If I calculate at zero point 0, say I'm just increasing the number of zeros, what's happening? It became 7 zeros instead of 4 here. And so on. So that means it's going towards 0. So the limit over here, as we apply 0 from the positive side, it becomes 0. Whereas if we calculate it at 0, you get a math error. You can't. So you should take 0.001 and so on. Now let's go to the next problem. Here, can we directly apply infinity? Let's try applying infinity here and here. These are the two terms, right? When we apply the square root, infinity square plus 1 minus infinity, what happens? The square root of, it's just infinity minus infinity. This is indeterminate form, IF. Indeterminate form means you cannot solve this. But now if we rearrange this and write it as fractions, like 0, 0 or infinity, infinity, then we can solve it by L'Hopital's rule. I've not yet told what exactly is L'Hopital's rule. Let me just tell you one thing. Imagine you have two terms, okay? X squared and divided by x. Now, if you rearrange and write this, now since here, if you have limit as x goes to infinity, right? This is in the form of infinity by infinity, which is indeterminate form. What you can do is, L'Hopital told you can derive these individually. You can derive the numerator, that will be 2x, and the denominator, and now apply the limit. Now let's apply the limit. If x is going towards infinity, what is the limit? To infinity, right? So it will be infinity. So this would be the answer for the given function as well, because given function we cannot apply limit of infinity. It will be in indeterminate form. That is, we cannot determine what it is. But in such cases, derive the numerator and denominator separately and then apply the limit, and whatever limit you get will be valid for this as well. That is what he had done by proving. So that is what L'Hopital's rule means. But now we have a condition, it must be in such form only. Any indeterminate form must be rearranged and written like this. But now, here we have square root minus x, and it is my infinity minus infinity indeterminate form here. So if you're writing in the exam, you can start with writing like this. There are specific problems. When you look at them, you need to do certain methods. Now this one, what you need to do is basically, let's start by conjugate. Whenever you see square root, you need to use conjugate. What does conjugate mean? I'll just focus over here. Limit as it is, this will be written similarly till we can get non-indeterminate form, in the sense proper forms. Now here, this is in the numerator, square root x squared plus 1 minus x, right? This will be multiplied with square root x squared plus 1 and x, but the sign will change as plus, divided by again x squared plus 1 plus x. Now then we can easily solve this up, right? In the numerator, what happens? The square root, see, it is like this term considered to be a minus b. Then we have a plus b. What is the formula for this? It's a squared minus b squared. So whatever this is there, the square root and square root will be whole squared. That will be square, right? It will be square root x squared plus 1 the whole square. So this square root and square cancels and you're remaining only with this. Minus x squared. So that is from the rule. Whenever you see the conjugate of square roots, the first term is the same, right? Just write it without square root. Minus x and x will be with square. Divided by, what is this? Let's write it out. X squared plus 1. Okay, that is it. Then separately x. Okay, that this x is outside the square root, so don't write it inside. Now, why did we do this is because you can see this is cancelled off. X squared and x squared is gone. The limit still remains. Limit as x tends to infinity. But now what happens is when we apply the limit, we will have 1 divided by whatever the limit is, right? So this helps us a lot. Let me show you how. I'll apply the limit. Applying the limit. So when we apply the limit here, it seems 1 is a constant. Nothing happens. No changes. What about the square root infinity squared plus 1 plus infinity? This is basically 1 by infinity, isn't it? So 1 by infinity plus infinity is basically infinity itself. What is 1 by infinity? That's 0. Why it's 0? Because 1 divided by infinity is a big number. When you divide something by a very huge number, it tends to become a small number, that is 0. Or if you have like this 1 by 0, this is infinity basically, because you're dividing by a small number that will be a huge large number. We consider it to be infinity. So now for this particular problem, this is your answer. It's just this first step, second step applying limit, that's it, rearranging. If you write so much, it's enough. That'll be full marks. Let's just look into what they have written over here. They've not written it properly, but I would highly suggest you to write all this what I've written. Even at the question, you can just see this is not equal to, don't write equal to this. You can just write like this, corresponding, okay? This is indeterminate form. If you're thinking how to write it in full words, that would be indeterminate form. Okay, all you just do is write so much, and this formula you do not need to write. This is just a basic one. You should know it by now many times. So what I written over here is plenty. I would ask you to write this below it. Okay, it will be like this, 1 by infinity, and lastly it is 0. That is the answer. So this is equal to 0. You don't need to write it horizontal wise, just write it vertically, one below the other. So that is how we solve this problem. I hope it is clear. Now let's move on to the next problem. And this problem is what I mentioned a while ago. Now if you apply the limits as infinity over here, what happens? So it'll be infinity, ln infinity, minus infinity. Okay, this ln infinity will obviously go to infinity, but it will take a very, very long time compared to the x. X will directly go to infinity. Let me show you why. So let us take our calculators here. Let me take ln x, okay, and I will calculate it at, let me take 10 nines, 1 2 3 4 5 6 7 8 9 10. Let me take 15, 1 2 3 4 5. Okay, there's 15 nines. The answer is 34.53. Now what is the other term? It's just x, okay, alpha x, and let me calculate. It's already there, right? That same value I'm going to calculate it at. You can see it is trillion and then this thousand, such a huge number, because when you take the same, even if I take less than that, it's so much more than 34. So what happens is this infinity is dominating the other one. So this is just dominating and this takes its own time, and this minus infinity is there, so you can just ignore this part. The answer is directly minus infinity. This is by reasoning. Now, if you have reasoned this properly and written it like that in words, I think so you should get full marks because you have understood it thoroughly and you're telling why you're doing it. But what I would tell you is to be on the safe side, let's do the method. Let me show you in methods how it can be done. So I would write this corresponding single and then a symbol and write infinity minus infinity. This is indeterminate form. You should write in full words, but I'm just writing IF, that is indeterminate form. Next then, here, how can we begin with? So you have this limit as x tends to infinity. Now there are different methods for different problem, but whenever you see this particular problem, right? Ln x. Now this is in infinity minus infinity. It is not as infinity divided by infinity. Okay, we can't directly derive above and denominator term. Why? Because it's not in this form. It is in the infinity minus infinity. We can't directly apply L'Hopital's rule here. So what can you do? Now there is an easy way to solve it. Whenever you see ln x minus x or x minus ln x, take an x common outside. Let's remove something outside. Why? Because now what do I have? It is ln x divided by x minus 1. Let me tell you what this means. See, whenever I took this x term outside, there is nothing. So basically, I'll multiply and divide by one x term. And this term is gone out, so I'm remaining with ln x. So I'm just balancing it off. If I cancel it's 1, it's the same thing, it's fine. So that is what I did. I just balanced it off. And now over here, right, ln x by x minus 1. Why? Because x is removed outside. Why did I do this? Now what happens is I got this x as a single value, and there is also one other important term. What is that important term? Here I can use L'Hopital's rule. It is in terms of this, isn't it? Ln x is infinity divided by infinity. So let us now only focus at this point, and I will tell you what will be the answer. Ln infinity, you can write this at the side, don't write it just below it, okay? You can write it's fine, but now this is in terms of infinity by infinity, and apply L'Hopital's rule, okay? We just write L means L'Hopital's rule is applied. So what happens here is ln x, what is the derivative of ln x? It's 1 by x divided by, what is the derivative of x? So this is ln x divided by x, okay? Limit as x tends to infinity. So only this part we are deriving. Ln x is 1 by x above, separately, and down. What is derivative of x? It is 1. So this is the numerator. This one is the denominator. I hope that's clear. So basically what we are remaining with is 1 by x. That's it. Now let us apply the limit. So limit is x tending towards infinity. Let me apply limit over here. So 1 by infinity is equal to 0, right? So what happens here exactly? If I apply the limit, let me applying limits. You will get infinity, and over here it will be 0 minus 1. Are you getting this? What just happened? I have done this L'Hopital's rule just for this. Why I did it separately is why I would suggest you do at the right is because we're not doing for the entire thing. Entire thing is not in this form. Only this particular term ln x by x is in infinity by infinity form. Then we can use L'Hopital's rule. Okay, this L'Hopital's rule means derive the above and below term, and therefore we get 0. So now here x, when you apply infinity, is infinity only. Now this term we saw over here, because of L'Hopital's rule, it becomes 0. Another way to analyze this, I'll show you how. Ln x, when it goes to infinity and x goes to infinity, which goes in a higher rate? This goes very, very slowly, whereas this dominates. So what happens is it will be basically by infinity. This is going to be by infinity. This will just be a number, constant, okay? So any constant divided by infinity is 0. There's another way to understand, because x will be infinity at a very quicker rate. So you can directly take it as 0 instead of doing this. But I would suggest you to do all this because you have understood it thoroughly by applying L'Hopital's rule. Now then, ln x by x is 0 minus 1. So what is the answer? This is basically infinity times minus 1, that is minus infinity. So the answer for this would be minus infinity. That is it. But these are the steps you have to write. Okay, these are the steps, very important steps. So, and over here also, you don't need to write this one, but this would be highly encouraged to write, because over here, when we, for these two terms, when you apply infinity, it becomes an indeterminate form of infinity divided by infinity. So applying L'Hopital's rule, we just apply infinity in both, derive both the cases, above and below, not by quotient rule. Remember, not by quotient rule. If we had 2x square by x, we don't, now x plus 2. Don't use the quotient rule. A by b, this b square, a derivative b minus ab derivative. This is not used because L'Hopital's rule tells above terms separate, below terms separate. So ln x derivative is 1 by x derivative is 1. I did it separately and then I applied the limit. That's how we go to solve this problem. And here, guys, the answer is directly mentioned. It's minus infinity. Now they have just told the numerator goes to minus 1. Okay, whatever method is done over here, you can follow the same method, but just the method which I did is much easier, I believe. Okay, now I'll tell you what they have done over here. They have taken this as divided by, but then you have to derive a long procedure, I think. So this is much easier, okay? We will do the method which they specified here in some time. In some problems, we will do this in the coming problems, okay? But whenever you have ln x minus x or x minus ln x, please do the method which I told, which is much easier compared to others. Now let's do the next problem here. Now this form again is indeterminate form. Why? If I start applying infinity, what happens? 1 plus 1 by infinity, the whole power infinity, right? So here 1 by infinity is 0. 1 plus 0, the whole power infinity, is basically 1 power infinity. Now this is again indeterminate form. Okay, by applying infinity, it's indeterminate form. How do we solve such problems? Whenever you see 1 power infinity, please follow this method, the same method throughout, which I'm going to tell you now. What is that method? So ignore the limit for some time. Let's just consider the given term. That we are going to take it as y. Okay, y equals 1 plus 1 by x, the whole power x. Now it's very crucial for us to get this down. How can we get it down? That can be, this power, we need to resolve it, because we cannot apply L'Hopital's rule in such cases. L'Hopital's rule can be applied by infinity infinity or 0 by 0. Then we can apply L'Hopital's rule L. Now here, if we take natural logarithm L, ln y, or natural logarithm y ln, will be equal to ln 1 plus 1 by x, the whole power x. Now for this first problem, I'll do all the steps, but later on I'll directly write this and all. See, now here what happened is ln x, imagine I have some power a, that is equal to, this comes down, isn't it? That's the rule of natural logarithm or logarithm functions. A can be multiplied, because when you multiply a ln x, or if you take a to the power, it's the same thing. That is the rule. That is why we are multiplying both the sides by natural logarithm. So we can bring ln over here, this x down, ln 1 plus 1 by x. Now this is very crucial. Why? Because now we can write this as denominator. We'll write this in a minute. But before that, what is missing here now? This is okay. But we have not written the limit. Let's take limit on both the sides. Limit as x tends to infinity for natural logarithm y, that is equal to, over here also, limit as x tends to infinity for this particular problem, ln 1 plus 1 by x. But here, when you apply x as the limit for y, what happens? Nothing happens. It's going to be ln y itself. Okay, there's no changes whatsoever. Only at the right side there is x term, so it will change. Now imagine you have limit of 0, x of 0 for 3. What is the answer? It's 3 itself. It's like a constant. There is no x term. If it was 3x, you multiply 3 times 0 and then it becomes 3. But here, what happens? There is no x term, so it's very easy. It will remain the same thing, isn't it? So that's why limit only will sustain at the right side because there is x. Now, how would we simplify this? We need as fraction. So I'll just write the answer here. It will be ln 1 plus 1 by x divided by 1 by x. Can anyone tell me why? The reason is, if I have, say, multiply a, now this ln1 entire thing, I'm going to take it as x. Is that okay? Sorry, let me take other way around. This entire thing, I'll take it as a. Okay, that is ln x plus 1 plus 1 by x. And I have x here. That is x over here multiplied to it. This is equal to what? Is it a divided by x? No. You can't write because this is multiplication, this is division. That's absolutely wrong. But this is equal to 1 by x. Why? Because if you have any term multiplied, it can always be divided by its fraction. I mean, by its inverse, basically 1 by x. That's absolutely right. This here is true. Or you can consider this to be minus 1, but it's better for us to write it as 1 by x, okay? This is absolutely true because this will come up. This is equal to a into x by 1, or it is ax, or x by a, x multiplied by a. So this is absolutely true. Why did we do this? Now, there is always limit, guys. If I don't write, don't forget it. You guys don't forget it. There's always this limit term here as well. It continues. Still, we apply the limit. Now, why is this important? Because now when we apply the limit, let's apply the limits. And then this becomes how much? 1 and 0. Okay. This is 1 plus 0. What is ln to the ln1? ln1 is 0 basically. Why? You can just check in the calculator. Natural logarithm of 1 is 0. And then what about 1 divided by x? So 1 divided by x is 1 by infinity. 1 by infinity is again 0. This is an indeterminate form. And you can apply L'Hopital's rule for this. Apply L'Hopital's rule. What happens over here? We had 1 to the power infinity, but we know we cannot apply L'Hopital's rule in case of 1 power infinity. We should get infinity by infinity or 0 by 0. Now we just rearrange. All such problems have to be done by this method. When we rearranged, what happens is when we apply now infinity, it's in the form of 0 divided by 0. Now we can apply the L'Hopital's rule. Let's continue. I would ask you all to write so much because I need to clear off some space. If you're finished writing, you can just pause the video and write it out. I'll take this off. These are a few basic rules. This is also one of the important rules which you applied, and this one as well. And now I'll write it over here in the second part. So let me just change the color. So here when we apply L'Hopital's rule, we have to derive the numerator and the denominator. What happens when we derive this numerator? This is gonna be derivation of ln x d by dx is equal to 1 by x, right? But instead of x, we have all this term, but still it's fine. Now limit is carried on. Limit x tends to infinity. Now we need to derive above and below term and then apply the limit. So 1 divided by, what is this term? 1 plus 1 by x. Is that okay? But it's not over. If it was ln x, it's 1 by x. What if it was x squared? It'll be 1 by x squared multiplied by 2x. Why? Because we have to derive whatever x squared is also there. So we derive this term now. What is this term derivation? 1 derivation is 0. 0, I'll just not write it. But what is derivation of 1 by x? So derivation of 1 by x d by dx is minus 1 by x squared. I hope you remember because x comes up, it'll be negative power, negative 1, and minus 2, then we take it down, it'll be positive 2. So I'll directly write it as 1 by minus 1 by x squared. This entire thing divided by this denominator term. See, this is numerator, numerator. Denominator, now we'll write denominator. What is the derivation of 1 by x? We just now wrote, right? Minus 1 by x squared. So this and this completely cancels off and you're remaining with only x tends to infinity. 1 divided by 1 plus 1 by x. Is that okay? So it's simplified here. Now, can we apply the limit? Yes, absolutely, because we have plus 1 divided by x, whatever happens, it just you can just easily apply and you'll get the answer. There is no other x term. It is not going to be indeterminate form. Let me show you. Apply the limit. Applying the limit. Here then, it will be 1 divided by 1 plus 1 by infinity. And let me just solve this up. 1 divided by 1. 1 by infinity is 0. So it's 1 by 1. Answer is 1. So whatever the limit at infinity would be, 1. So that's it. Oh, sorry, it's not over. I'm so sorry, guys. We got answer of 1. Very good. But what is 1? The limit, see this one, ln, right? We applied ln and we did it. See, can you see that 1 divided by y? Why did we do that? Because we wanted to write in fractions. Now this over here is solved with limits, okay? So this over here with limits was solved. Okay, this practically, I'll just write over here also the limit as x tends to infinity, because if you put x tends to infinity, it doesn't matter, right? This here is solved. So whatever this answer at the right side, we solved it, right? From here, see, here we solved it. That is equal to what at the left side? ln y is equal to 1. This is very important. It's not the final answer. The answer of limit is not 1. This is not 1. Ln y is 1. But y we need, because we just applied, see, this is considered to be y, right? So we need to solve this up. What is y? Now, how do you remove this natural logarithm? Take its inverse. Exponential e ln y is equal to e to the power 1. This cancels. You will have y is equal to e to the power 1. This is your final answer. The limit over here is e power 1. Now, what happened over here? If you have ln x, okay, all you do is, and over here you have 1. If you can just do this, ln to the other side would mean x is equal to e to the power 1 directly. In the other questions and all, in the next questions, you don't need to do this step. If you have ln, say 2 here, directly y will be e to the power 2. That's it. E to the power 1 is e itself. So this would be the final answer. We can check this in the calculator. All you need to do is write the given question. It's 1 plus 1 divided by alpha x, close the bracket here, and to the power x. And what do we do is calc at infinity is a big number. I'll just write few nines. You can see it's 2.71828. What does that mean? That is the Euler's number e. Shift e to the power 1 is 2.71828. So that is the answer. It's a bit lengthy, but these are all the important steps which you must do. You do not need to write what I've written. Oh, this is that's fine. This is important, whatever I've written over here, right? So if you write so much, you'll get full marks, and this might be for 8 or 10 marks because these are lengthy problems. Okay, let's move on to the next one. See, the answer is E only. Now I'm sure they have not done all the steps. The actual steps would be this. Okay, this is like in detail. I've done all the steps here as well. Now when we apply, what's gonna happen? What is the degree over here? 1, degree here 1. What happens when you have degree 1 and you're taking to infinity? You should just look into the coefficients. It'll be 1 and 1, so 1 will be the answer here when we apply infinity. And what about this? To the power infinity. Why? Because infinity x squared, infinity squared is infinity, minus infinity also infinity, root of that is infinity. So again, it's indeterminate form. Okay, what is the indeterminate form? 1 by infinity. I'll just write over here. Now if you're thinking how this term became 1, imagine you have x squared minus 2 divided by 3x squared plus 5, and the limit is towards infinity. See, the 2 degree in the numerator and denominator is equal, isn't it? In such cases, you do not need to apply everywhere infinity and check. All you can do is, see the first term. What is the first term? It's 1, the coefficient, divided by 3. That is the answer. I'll show it to you. Let's take our calculators and prove this up. Here I'll type this out. It's x squared minus 2 divided by 3x squared plus 5. And here calculated at infinity, that is a big number. What is it? 0.333. It's 1 by 3. Even over here, you can just write this up only for this part, inside part. If you're wondering how I got 1, it's x plus 1 divided by x minus 2. And now what do you do? The power, here it is. No, you don't have to put the power, I'm sorry. Why? Because I'm just checking for the term within over here, the base only, calculated at many nines. The answer is 1. Okay, now if you want to check what is over here, you can check it by the calculator as well. You'll get infinity. So now then, if this was the form, what did I tell you? You must take y. I'll directly write over here ln y will be equal to this power c, because it's the same steps what I done in the last problem. Starting will be same. You have to take this as y, take the ln on both the sides, that's natural logarithm, and then you need to solve. I'll directly take it. And over here limit x tends to infinity. This whatever is the power will come down because ln is there. So I'll have square root x square minus 4. When we solve this, remove this magnitude. It's just that we have to take only positive inside this. That's fine. And over here, what we do, because it's infinite, it'll be positive. It's fine. Ln x plus 1 divided by x minus 2. I hope this much is clear from the last steps. I directly brought this power down and did it. If you're getting confused, just go to the beginning of the question 33 and we have done this. Now I will start solving it. Here, this is the numerator. So let me write first limit as x tends to infinity. The numerator will be as it is ln x plus 1 divided by x minus 2. This much is done. This entire term we will write 1 divided by square root x square minus 4. Okay. Now if you apply the limit, what's going to happen? Here it is 1 by 1. ln 1 is 0. It would be 0 here. What about this? 1 divided by infinity is again 0. It's indeterminate form. So I can use L'Hopital's rule. Applying L'Hopital's rule. Okay, L rule I'll just write. This is L'Hopital. It'll be given in the question, I believe. And now what happens is you have to derive these. Now what is the derivation of ln a by b? Now imagine a by b was in terms of two x's, okay? Like instead of x plus 1, I'm writing a and b. The answer would be b by a. Then you need to derive this altogether, multiplied by, what is the derivation of ab? It is a quotient rule. B square will be a derivative b minus a b derivative, or prime. So this is the term. When you have two terms, a and b, provided that function of x, it's solvable, you need to write first b by a. Why? Because it'll be 1 by a by b, right? This, when you bring it up, this comes up over here. It'll be b by a. So that's why I've written it directly. I hope that's clear. And then what else? Whatever is these two terms, you need to derive them as well, right? That time you'll get the derivative rule. So let me solve this up, above term. So here first, when I write this 1 by 2, this denominator comes up. See, now I'll write the numerator, denominator, okay? Let me just change the color over here. So this one will be for numerator, that will be x minus 2 divided by x plus 1. That is just flipping these two. Then I'll have to multiply it with what? With the derivative quotient rule. Whatever is the denominator, you square it up. X minus 2, 2 times square. What about the numerator? What is the derivative of a? Derivative of x plus 1 is 1. Same, 1 only, okay? 1 multiplied by anything will be the same thing. What is over here? B term, I have to write it as it is, x minus 2. Minus, what about above term, a? Write it out as it is, x plus 1. And then, when you derive the b term, it's going to be 1. So I'm not going to write it. Just multiply by 1, it remains the same. So that is the numerator. What about the denominator? How can we derive this? Now, see this square, it's 1 by square root x. So what do we do is, we bring this up. Basically, what's the power of root? It is half, isn't it? This is half. So we can get it as negative half, x to the power minus half directly. So I will write this over here as, instead of 1 by square root x square minus 4, I should have done it before and then I should apply the derivative on both. this numerator, and then it would have been, instead of half, it will be x square minus 4 whole power minus half. I hope this is clear. This entire term becomes minus half. Why? Because 1 by square root is whole power half. When we bring it up, it becomes minus half. So that is the term here. This is the term. But now I will directly derive this term. Derivation of x power minus half. What happens? It will be negative half. And then you have x. Half minus 1 would be minus 3 by 2 or 1.5. So here what I'll write is, basically, I'll just write it over here. It will be minus half multiplied by x square minus 4 the whole power negative 3 by 2. Here there is a very important thing not to forget. After this, you need to even derive what is inside, isn't it? Now, if you're deriving x to the power minus half, it's just this. But if it was something else, if it was 2x or something, you have to multiply even that term. Say now, this is done. This x square derivation is 2x. It's the chain rule what we do. So now here you can see there are things that cancel. This 2 and 2 cancels off. What about in the numerator? If you look carefully, this 2 is there, right? Power 2 cancels off with this term here. That cancels off completely. And now we have, this is the denominator. Now we have to write what is remaining. Let me write it down here. In the above term, see this minus, right, is multiplied inside distributive property. So it becomes x minus 2 minus x minus 1 divided by, what are the two terms remaining? X plus 1, x minus 2. I hope this much is clear. And then what do we have here exactly? Here we have only this, don't write this n and d, this is numerator and denominator, that's it. Divided by minus, the numbers are cancelled, so only x is remaining here, divided by, what is this? Sorry, nothing is down, only above it's this. Sorry, let me just, there is no down term because this 2 is cancelled, so it'll be x times this entire thing. Minus sign remains, minus x times x squared minus 4 the whole power minus 3 by 2. I hope this much is clear. Minus 3 by 2. You're just writing them as it is. Now let's simplify this over here. This minus x plus x cancels off. So what happens here? Minus 2 and minus 1 is minus 3 divided by, now let's multiply this inside, FOIL rule. X times x is x squared. X times minus 2 is minus 2x. 1 times x is plus x. And lastly we have minus x. Minus 2, sorry. Divided by, what remains here? Here we have, okay, we will not write that over there because there is a rule. See, now imagine you have a divided by b, this whole thing divided by x. What happens here? This is equal to a by b multiplied by x, right? So I can write it out over here itself. See, this term multiplied by this entire thing. What is it? Minus x times x squared minus 4 the whole power 3 by 2. This is it. They're all multiplied, okay, to each other. So that is mainly it. Sorry, let me just remove that closing bracket over here. This one is multiplied with this term, and but this power is minus, so they're all in the denominator here. Only 3 is up. But here if you look carefully, what is this minus 3? So if I have x power minus, say, 3 by 2, over here it's already 1 divided by any number divided by, this is equal to x power 3 by 2 in the numerator. I can take any power up, but the sign changes. So what I would do over here is minus 3. Now 1 minute, do we need this minus? No, minus and minus sign cancels off, so I'll remove that minus off. Okay, now here then let me write it out. See, there is x term which I need to multiply throughout, but that I'll do in the next step. It'll be too much at once. 3 multiplied by x squared minus 4 the whole power minus 3 by, sorry, it will become plus 3 by 2. Why? Because I took it up. Divided by x squared minus 2x plus x is minus x minus 2. Multiply all this by x. What happens? This will be equivalent to 3 into x squared. Now, if you multiply this power inside, what happens? You don't need to multiply. I'll just leave it. I'll just tell you in a minute. It's 3 by 2 here divided by x power 3 minus x squared minus 2x. So this is the simplified answer. But here, are the degrees same? The highest degree over here is 3. Now, you don't need to apply the rule a minus b the whole square. No need of any rule. Just multiply these two powers and see what happens. 3 by 2 is how much? Multiplied by 2, it will be 3. So it will be x power 3. The highest degree in this term can only be x power 3, nothing else. And it's a single term. When you multiply 3 inside, it will be 3x power 3. So we are not going to solve it all. Just reason it out. Your highest degree over here will be 3x power 3 and the denominator is x. Why are we writing this? Because we know over here everywhere we have limit x tends to infinity. We have not written, I have not written it, but you need to write it over here. It's x infinity. This is, I don't have proper space, so I've written it, horizontally as well, but better to write vertically, and limit is always there. Here also we have this limit x tends to infinity. Now, when we know this rule, I've already mentioned it before. When you have coefficients of the same degree, this down term is x power 3. This and this is same, right? What is the limit? Whenever you apply infinity, these go off. The answer is 3. So the limit over here for infinity is 3. So this entire thing over here, when we solve it up, is 3. So this is a very important, but now we are still not done. There is a small step remaining. What is this 3? That is equal to ln y is equal to 3. I told you y will be the final answer, that is e to the power 3. To remove ln, just take exponential. So this is the answer. E to the power 3 is the final answer. So let me show it in calculator as well. So now let's put this entire question in the calculator. I think I moved ahead. This was the question. So here, just type it out without that, you don't need to put the absolute value. It's x plus 1 divided by x minus 2 to the power, we have square root x squared minus 4, and take the limit that is calculated at 999. You get 20.08 and so on. Why? Because e to the power 3 is same thing, 28.08, and it goes on. So that is why this is the correct answer. I hope that is clear. So the final answer is so on. You need to do all the methods, and that is the thing. It's a bit lengthy one. Now let's look at this problem here. Now this one, as you can see, there's no power, so it won't be like the same previous problem. There is no ln y. Let's just apply the limits and see what happens. Over here, when it's 1 divided by 0, it's going to be infinity. Minus, what happens here to the right side? It'll be 0 divided by 1. So it's 0 here. Is this indeterminate form? No, not indeterminate form. So here we are not going to use L'Hopital's rule. We will just do basic algebra and try to simplify this. How could you simplify? So I can see that, let me try taking common terms. This can be written, this entire term, limit as x tends to 0 from the positive side, 1 by square root x minus square root x divided by square root x plus 1. This is the way to simplify it. And now let me take the common term. How do we do that? You multiply this denominator up and down here and this denominator up and down. Let me just show you over here. Whatever is this denominator, square root x plus 1, here also square root x plus 1. This is square root x, square root x. Now if you see, the denominators match. Here the denominator is what? Square root x and square root x plus 1. And above will be square root x plus 1. What about this? Minus, again, square root x and square root x plus 1. Or you can write this first, it's up to you. And here square root x and square root x will be 2 times square root x. It's x, but I'll just write this. Now let's simplify. The denominators are same. Square root x multiplied by square root x minus x plus 1. And what happens over here in the numerator? It is square root x plus 1 minus x. Now here, can we apply the limit? Everywhere you should write the limits, guys, at the left side. Let me just try applying the limit. Here it'll be 0 plus 1, it's 1 minus 0. It's 1 divided by something, it's 1 divided by 0. Yes, we can apply the limits. Let's apply limits. Applying limits. You can directly apply the limits. You do not need to write as well. It'll be 0 plus 1 square root minus 0 divided by 0 multiplied by 0 plus 1. Here it's going to be 1 minus 0 divided by 0 times square root anything. 0 multiplied by 0 is 0. So it's 1 by 0. What is 1 by 0? It's infinity. So the answer is infinity, the limit. You can just try this in the calculator. Put this entirely in the calculator. Take the limit of 0.0001. Calculate the value. You will get infinity, a big number. That's it. So here, answer is infinity. But you need to do the steps. Only 2 steps are done. But these are the exact steps, okay? Now we'll go to another problem. This one is also same, easier. Why? Because if you don't have power, it's easier. But I highly feel that, the power problems might be asked in the exam. That's why please study them thoroughly. Now here, what do we do is, let me first apply the limits and check. If I apply the limits, it's going to be square root 4 minus 2 divided by square root 9 minus 3. It's going to be 2 minus 2 divided by 3 minus 3. Oh, it's 0 by 0. This is indeterminate form. I can but apply L'Hopital's rule. Why? Because it's 0 by 0. In this form we can apply easily. So let me derive the above term and below term. This seems to be a very easy problem because they have directly handed you 0 by 0, which is a easy L'Hopital's rule. Square root is 1 by 2 root x is square root 5 minus x. Multiply. Okay, now this is the derivation of square root x. D by dx of square root x is 1 by 2 root x. But here, it's not just x. There is 5 minus x as well. What is the derivation of 5 minus x? It will be minus 1. And minus 2 will be 0. Divided by, again, 1 by 2 square root 10 minus x minus 1. I hope this is all clear. And now what else do we have? After this, let us just rearrange it. This minus 1 and minus 1 cancels. The negative becomes positive itself. Limit x tends to 1. Let me just rearrange and write. See, imagine you have 1 by a divided by 1 by b. What happens? This becomes b by a, because 1 by a remains, and this term will be b divided by 1 multiplied to it, so b by a. So I'll write this above. It's and 2 cancels, okay? So I'll just simplify and write square root 10 minus x divided by square root 5 minus x. Why? Because this is the form. And now then, when I apply the limit, okay, now I can easily apply the limit. When I apply the limit, it's going to be square root 10 minus 1 divided by square root 5 minus 1. That is square root 9 by square root 4. That is 3 by 2. It's 1.2. So the answer is 3 by 2. And yes, that's it. If you apply in calculator, also you should get this. I will show you in the calculator now. Here, all you do is write this given function. That is root 5 minus x. And go out of that square root, and minus 2 divided by again square root 10 minus x. And over here go out, and it's minus 3. Now calculate 1. Okay, it's an error because we saw it was 0 by 0. So you don't take 1, take 1 point, okay, not over here. Calculate 1.00001. The answer is nearly 1.5. And also we can calculate it in the negative otherwise, not 0.999. Not minus, sorry, it's 0.9999, which must be very close to 1. It's either 0.999 or 1.001. You can see the answer is nearly 3 by 2. 3 by 2 is 1.5. So that is the correct answer. And now we have 1 by x. So here, when I look at it, I know it's in an indeterminate form of power. See, 1 by 0 becomes the whole power 0, right? It'll become infinity to the power 0, which is indeterminate form. But here the thing is, yes, it's an indeterminate form, but can you directly use L'Hopital's rule? No. I have to write that term L N Y because whenever I told you the power is the exponent is the, you have to write it like this. So let me write L N Y. Over here I directly write limit as x tends to 0 positive. I had done few 2-3 steps at the beginning, right? You have to write that over here, but I'm directly writing it because it's just taking ln on both the sides and then applying limit. And over here when you apply limit x tends to 0, it's the same thing, but here you will have this x comes down ln 1 by x. I hope this much is clear. Now this can be rewritten limit as x tends to 0 from the positive side ln 1 by x divided by 1 by x. Now then let's derive. What is derivation of ln 1 by x? See, ln derivation of 1 by x, that is equal to 1 divided by 1 by x, but we simply write x. I hope this is clear to everyone. Instead of writing 1 divided by 1 by x, sorry, ln x or ln x 1 by x will be x. Just remember that that's the rule, you know, ln x is directly x. So what I do over here is limit as x tends to infinity. Instead of writing ln 1 by x, I'll directly write x multiplied by derivation of 1 by x is minus 1 by x squared. Now divided by, what is derivation of 1 by x? Again, it's minus 1 by x squared. I'm sorry guys, here the limit I wrote infinity, okay? It is 0. See the question, there was 0 from the positive side. This and this cancelled. So what is remaining? Limit of x tending towards 0 from the positive side for x. Apply the limit, it's going to be 0. Do not forget whatever the answer is there, that is ln equals y. So here it's ln equals y, isn't it? So y will be equal to e to the power 0. What is e to the power 0? Literally anything to the power 0 is 1. Other than infinity to the power 0, it's undefined, indeterminate. But otherwise, it's 1. Any number here. So the answer is 1. Simple as that. If you just put in the calculator and solve it at 0.00, and then you will get 1 as well. So that is the correct answer. And now we will move to another problem. Again, it is similar. No, is it similar? It might be a little different. Anyways, let's solve it up. So first, apply 0 and try to see what is happening here. So let me apply this as cosine 0. And then over here, 1 divided by 0. What is this? 1 divided by 0. What is cosine divided by 0? If you recall, sine 0 is 0, cosine 0 is 1. So it's 1 to the power infinity. 1 by 0 is infinity. So this is indeterminate form again. So now can we use L'Hopital's rule? Yes. But what happens is, before we apply L'Hopital's rule, we have to get it in terms of infinity by infinity or 0 by 0 in this indeterminate form. So how do we do? Again, whenever the power or exponent is there, what did I tell? You have to take ln y is equal to limit as x tends to 0 from the positive side 1 by x ln cos x. If you're thinking what just happened, please go back to the previous problem. I think so question 33. Everything is done in detail. Every question will get this form. After you take ln on both the sides, this comes down, and take limit on both the sides, and this much will be the this. After 3 steps you'll get this. Now let us start solving. This is 1 by x here. Can I just write it as ln? Look over here. Now you have directly 1 by x. So I'll write ln cosine x divided by x. Don't need to do 1 divided by anything because it's already 1 divided by x. It's in the denominator. Now you can see here I've got the numerator, denominator, and let's now apply 0. If I apply 0 over here, what is it? Cosine 1. Cosine 0 is 1 basically. ln 1 is 0 divided by 0. Why? Natural logarithm of 1 is 0. This is also 0. This is again indeterminate form, and apply L'Hopital's rule here. Why? Because it's in 0, 0. Or if it was infinity, infinity also, you can apply L'Hopital's rule. So now then, I will apply L'Hopital's rule. That means you have to derive the numerator and the denominator. So what do I do is, Just let's derive it up. It will be 1 by cosine x. Why? Because natural logarithm x derivative is 1 by x. But over here we have cos x multiplied by derivation of cosine x is minus sine x. Divided by what is the derivation of x? It's just 1. So what is this? What did we get? Limit as x tends to 0 from the positive side, we will have negative. Sine by cos is what? Tan, right? Negative tan x. Now let's apply the limit. What is tan 0? If you just apply the limit over here, you will get minus 0 is 0. I'll directly write it as 0. But this is not the answer. You need to understand this is ln y is equal to 0. So y is equal to, you just have to take this, y will be equal to e to the power 0. So this is the final answer. Or what is e to the power 0? It's 1. Anything raised to the power 0 is 1. So this is the final answer. You need to write this up. These are the exact steps. You do not need to write this one over here. Okay, this much, whatever is there to the screen, needs to be written for this particular question. I hope such questions come. They are easy ones. And you can see the answer is 1. Now we will go to the next one. This is a bit difficult, and the last one is really difficult. Now here we have done similar problem. Do you remember the modulus to the power something? That is similar to this itself. Let us solve this up now. First, apply infinity. When we apply infinity, see the degree. This is 1, this is also 1. So what happens? It will be 1. Okay, this cancels. So just 1. Then what is power infinity? Power t is infinity. So this is an indeterminate form. We do not know what is 1 power infinity because 1 is just 1 and infinity is just a large number. It is indeterminate form. But we cannot apply L'Hopital's rule just yet. Why? Because we need to rearrange and write this in either infinity by infinity or 0 by 0 form to apply L'Hopital's rule. Here, whenever you see the power or exponent that is there, we directly jump to the method of natural logarithm y equals limit as t tends to infinity. What happens? This t comes down because that's the natural logarithm property, and we have t minus 3 by t plus 2. If you're thinking why, again, please go back to the question 33 where everything is explained in detail. We are just considering this term to be y, and we are taking natural logarithm on both the sides, which will help us this t power to come down. Now then, this I will write it as limit as t tends to infinity, natural logarithm, let it be ln, on the numerator t minus 3 by t plus 2, divided by what happens to this t? This t can be written as 1 by t. That is same because 1 divided by anything in the denominator goes up and multiplies, right? It's the same thing. Now this is 1 by t. Now let's apply infinity and check. If I apply infinity, it will be ln 1. ln 1 is 0, so this above term is 0 divided by 1 by infinity is 0. It is indeterminate form. Apply L'Hopital's rule. Okay, now we can use L'Hopital's rule. What is L'Hopital's rule? You have to derive this. We have done this similar problem before. So let us derive limit as time t tends to infinity. They will not mention its time or anything. Now, derivation of this, you're just inverse these two. T plus 2 goes up, t minus 3 goes down. Multiply it with this product rule. That is t plus 2 the whole squared. Derivation of the above term is 1 multiplied by t plus 2. See, the rule of a divided by b is a prime b minus ab prime divided by b squared, isn't it? The same thing. We derive the above term, gone, it's 1. And the below term, what happens? We will have just t plus 2 remaining, minus here the above term will remain, t minus 3 will remain, the next term will be 1. And now we can see cancel this and this off, but still the down term is still there. What is 1 by t? It is minus 1 by t squared. This is the derivation of 1 by t. I hope so much is okay. Now once this is 1 over here, negative 1. Now once this is done, what can we simplify here? See, this above term, right? will be t minus and minus will be multiplied inside. It will be t plus 2 minus t plus 3. Why? Because this 3 is minus is multiplied with this minus 3. Now what remains down is t minus 3 and t plus 2 divided by minus 1 by t squared. But I'm not going to write it down. What I'll do is I'll take this above and you just have to flip this. It'll be t squared by 1, and don't forget the minus sign. That's it. Now let's simplify this. It'll be t and t cancels off. You will have 5. Sorry, 2 plus 3 is 5 minus t squared. Over here it will be t squared minus 3t plus, sorry, plus 2t. T times t is t squared plus 2t minus 3t here. I'll just rewrite this entire thing. You need to be very careful with this. T times t is t squared. T times 2 is plus 2t minus 3 times t is minus 3t minus 6. And this 1 is 1. And here, now when we simplify this, what happens is minus 5 times t squared divided by t squared minus t minus 6. And now what we do is, okay, that's it. What is the left side limit? Limit is x tends to infinity. Since it's limit of infinity, do we need to do anything further? No, because over here we have same degrees, right? So the limit, when you apply infinity, you will get over here as minus 5. So ln y is equal to minus 5. So what is y? It is e to the power minus 5, and that is the answer here. So just in these steps you get it. I mean, it's not that difficult, only so many steps. So you are, I mean, it's not easy also, but it's not that difficult if you understood the gist of it. If you understood the first problems, then this is, the similar way. So this is how we solve it up. And you can see the answer would be e to the power minus 5. You can also check it in the calculator and you can get the correct answer, same one. But you need to do the steps, so please follow these methods. Whenever you have exponent, it's always this. So let's do the last problem here. Finally, we reach the last problem. Again, let's check whether it's infinity. So over here, what happens when we have limit? What is the coefficient here? It's 1 divided by, what's the coefficient over here? It's 2. Half to the power infinity. Now here, is this indeterminate form? This is not indeterminate form. Okay, this is not an indeterminate form. So we are not going to apply L'Hopital's rule. But still, you have power infinity. We have to do the same step of ln y. This is natural logarithm y. Ln y will be equal to limit as t tends to infinity. What happens? T comes down and you have ln over here multiplied with t minus 3 divided by 2t plus 1. Now here then, this power has come down. But if you rewrite it, now if you apply the limit infinity, what happens? It's half. Ln half is not 0 or 1. You won't get indeterminate form. You can't apply L'Hopital's rule. So we can't derive the above and below term at all. Even if you do, you'll get the wrong answer. So what we do in such cases is, you can recall applying limits. We see the degree, right? What is the highest degree here? It is 1. 1 is the highest degree. So whatever is the t to the power 1, you divide it throughout by that. Let me show you what happens. It is limit as t tends to infinity. Here, let t be as it is. Okay, I'll just write this t as it is. Here, what happens with this? ln t divided by t minus 3 divided by t divided by 2t divided by t plus 1 divided by t. What did I do is just all these terms I divided by t for each term. Now, if I simplify this, what's going to happen? Left side is going to remain the same thing. T tends to infinity, t times ln. Now here it's going to be 1 minus 3 by t divided by, over here it's 2 plus 1 by t. And now we can apply limit of infinity. Let's just apply infinity and infinity. This is a single term. This is one more term. So what happens over here? This is infinity. Let me write it out over here. Infinity, okay? And what happens over here? Multiplied with, this is all multiplied, okay? ln, when I apply infinity, this doesn't affect, 1 remains 1 only. But what happens to this part over here? Minus 3 by 2, minus 3 by t. Whenever you are 1 by t, when t is infinity in the denominator, it's 0. So 1 minus 0 divided by 2. 1 by infinity will be again plus 0. Okay, so this is why we did it. Now infinity will be equal to what? Ln half. Okay, this is the thing. What is ln half? Now let's take our calculators and solve. Now here there are two ways. One is direct calculator method. What is ln half? Ln of half will be, it's negative some number. So any number multiplied by infinity will be infinity, but it becomes minus because this is minus, isn't it? So it will, the answer is minus infinity. That is one way. That is the easier way, I can say. It will be directly infinity times minus some number, okay, minus um, uh, 0.69 or something. So it will be minus infinity. But there is another way to do this. I will show you now what that means. Here ln half is there. What is this? It is ln 1 minus ln 2. Why? Because the above term is 1 minus this denominator. That's the rule, right? If you have ln a by b, that is ln a minus ln b. Numerator will be first minus the denominator. Now in such cases, what is ln 1? 0 minus ln 2. So negative sign, whatever answer is there, doesn't matter. It's 0.69, yes. It's 69 here also. But minus sign will remain. When you multiply this with infinity, it will be minus infinity. That is another way to understand. But the easier one would be just put this in the calculator. You got this minus, so it's minus infinity. But we are not done. Ln y is minus infinity. So what is y? E to the power negative infinity. Now what does negative infinity mean? It goes where? Now how would you graph exponential function? If you see the graph of exponential function, it's like this, right? What happens when x is infinity, when it's a big number? You can do it in calculator, but I just want you to easily understand this. When we are in minus infinity, y is 0 over here. This e to the power minus infinity is 0. So its answer is 0. The limit over here is 0 basically. Let me show you in calculator. E to the power, just do e to the power minus x. And let's take x as, calculate x at big number. It's 0. Okay, so that's the thing. Or you can just put this entire thing in the calculator. Let's do it. X minus 3, that's minus 3 here, divided by 2 times x plus 1 to the power x. Now calculate it at what? Infinity is a big number. What is the answer? It's 0. That's how we can solve it. But the only difference is you do not need to write all this. The only main thing over here, what is it? It is not indeterminate form. You cannot use L'Hopital's rule. You have to apply the normal method, just by dividing by the highest degree. So you need to see whether it is an indeterminate form or no. That is the most important thing. And then you apply L'Hopital's rule. Whereas in the previous problem, we applied L'Hopital's rule. We derived above and below. But here, no. We're not deriving above terms. We're just, dividing by the, the highest degree power term. And then we are just sorting out by applying limits. And easily we got the answer minus infinity. With this over here minus infinity, but e to the power minus infinity is 0. That's how we solve it. So that is how we solve all these problems. They have done some other method, but I would suggest you to go with this method. It's easy to understand. And now this method, right, will work in any problem, what I've just told you. If it's indeterminate form, L'Hopital's rule. Otherwise, just this method. Every time it will work. And that is the end of all the writing part. I wish you all the best. And please do practice many problems. Just a quick reminder, if you're finding my videos helpful, please do share them along with your friends. That would help me a lot. And please do subscribe to my channel. Take care, guys, and I will see you all in the MCQ part.